Welcome to Chemistry with Caroline. In this video, we're going to look at IBX and the Dess-Martin reagent. These are both iodine-containing compounds that are used to oxidize alcohols to aldehydes and ketones. You can see that the iodine has quite a few atoms around it here. Remember that iodine has d orbitals available to it, so it can have an expanded octet. Its valence is 7, so in both of these compounds, it has a total of 7 electrons assigned to it, and it is neutral. Because of that expanded octet, it can help facilitate the formation of the double bond in the alcohol of interest. The main difference between these two is that IBX has limited solubility in organic solvents, which is problematic because most organic reactions happen in solvent, and carbon-based molecules are going to be primarily soluble in an organic solvent. So you see a little bit more limited use of the IBX because of the solubility issues, but they show the same selectivity, and that is that they can make either a ketone or an aldehyde. So let's go to the next slide and we'll take a look at one of the intermediates and how this formation of the carbonyl compound is facilitated. Okay, so here I've drawn IBX for reference down here. So this is IBX down in the corner. That's what it looks like. And essentially we've swapped out this OH for our alcohol. So here's the alcohol of interest. I just did a generic one, so I have an R group on there. So there's the R group there. There's the R group there. And the iodine is going to attach to the oxygen. And so that will be what accepts the electrons when the proton is taken off and the new double bond is formed. So let me go grab a different color here. Do this guy. So this oxygen that is double bonded to the iodine, this pi bond can come off and grab one of the protons off of the carbon with the oxygen on it from our original alcohol. Those electrons will fold over to form the double bond. Now, if you've seen the mechanism for PCC or chromic acid or bleach and tempo, this should start to look familiar. You're going to form a new double bond, and then the bond between oxygen and iodine breaks. So basically, all of IBX is acting as a leaving group, accepting those electrons with it in order to not break the octet rule, and that can form the new double bond. And so now what I get over here is this product where I've got my carbonyl compound that formed the new double bond right there, and then the IBX left with that lone pair of electrons in order to facilitate the formation of the double bond and oxidize the species. So we'll just look at a difference between primary and secondary alcohols. Remember, in order to oxidize, you've got to have a proton on the carbon that's attached to the alcohol. So for a primary system, you would have 2 protons. For a secondary system, you only have 1. So whether you use IBX or Dess-Martin or PCC or chromic acid or bleach and tempo, any secondary system can only be oxidized to a ketone because there's just that one H. With a primary system, there is a difference. You could either make an aldehyde or go to the more highly oxidized carboxylic acid. Both IBX and Dess-Martin are selective for the aldehyde. So if you want to make an aldehyde selectively, IBX or Dess-Martin are great reagents to use. They're chromium-free, and they can selectively stop at the aldehyde, and you won't see further oxidation to the carboxylic acid. So this has been a look at IBX and Dess-Martin as oxidizing agents to form aldehydes and ketones from alcohols. If you found this video helpful, please like, subscribe, and share with your friends. Thanks.